So this is the last subtopic in this chapter, Joules law. This is related to heating effect of electrical current. There are few devices which converts electrical energy into heat energy. So related to that, there is a formula which is known as Joules law. Okay, in this video I have explained Joules law. Like these two appliances, electric iron and electric heater, they convert electrical energy into heat energy, so they work on heating effect of electric current. Even this light bulb is looking very happy over there. Okay, there is a filament inside, tungsten filament, and when current flows through it, it starts to glow due to heating effect. So when you heat any metal, you know that it will start to glow. So it's all about heating effect of electric current. Now there are few formulas. Okay, basically it depends upon the heat energy. Heat energy which is produced depends upon current, resistance. Resistance. Each and every substance is having a resistance. Here we are talking about conductors, resistance, and even time. These are the three factors on which heating effect depends. Why time? Because it takes time to heat up, right? Well, in this case, it's quick actually. Instantly, it will start to glow. But there are some devices which takes time to heat up. Like in these two cases, it takes time to heat up, right? So heat depends upon amount of current flowing through the conductor. I mean the devices, its resistance and time. These are the three factors on which heating effect of electric current depends, right? They take some time. Okay, they don't get heat up easily or quickly. They take some time to get heat up. The Joule's law formula looks like this actually. Okay, this is the formula for Joule's law. I mean heating effect of electric current. Q, this Q stand for heat. In your textbook they have used H actually in place of Q, because Q we are using for charge, right? So uh, we will not use Q here, although in calorimetry chapter we used Q, right? If you remember this formula, Q is equal to PT, Q is equal to MC delta T. I hope you remember in case of electrical heater. Okay, so we can use Q as well, no problem, but here since this is related to electricity and Q we are using for charge, so they have used H in your textbook. Again, this is the formula. Let me read this formula first. I square RT, I mean heat produced in a device or in a conductor depends upon current, square of the current, resistance and time. Time is important here because like I explained, some devices take time to heat up, right? So yeah, I mean if you pass current through any devices for a long time, okay, more heat will generate. So these are the factors on which heating effect depends. Now we will derive this formula actually. Okay, I am going to derive this formula. I will come back to it. So before I derive that formula, okay, let me derive these formulas first. These are very important. Once you understand these formulas, you can understand the Joule's law of heating effect of current. So this is the basic formula we are aware of: power, work done per unit time, right? So basically we are talking about the electrical appliances. Each and every appliance is having its own power rating, so uh, they convert light energy sorry electrical energy into heat energy, right? So in place of W, W stands for energy, right? So uh, let me derive this formula first using Ohm's law. Ohm's law, what is Ohm's law actually? V is equal to I R, right? And there is a basic formula for potential difference. What is potential difference? Potential difference, I mean V nothing but the work done on per unit charge, right? When you connect a battery, it pushes the electron through the circuit. I mean it is doing work on the charge, and This is the basic formula for potential difference. And what is the formula for current then? Current is nothing but the flow of charge per unit time. So these three formulas, using these three formulas, I will derive all these new equations, right? These are new for you, new formulas, but not to worry. Once you understand these three formulas, once you know these three formulas, you can also obtain the remaining ones. Okay, so let's begin then. Now let me begin. Acha, let me write the formulas here. Work done per unit charge is formula for potential. Okay, and for current, let me write it somewhere here. Current is nothing but the flow of charge per unit time, right? Acha, now here let me use this formula, formula of power, and let me derive this equation first. ठीक है ना? So power, work done per unit time, चलो ठीक है. Now I'm going to replace W over there. So अगर मैं इसको यूज़ करता हूँ, what is work done per unit? पोटेंशियल का फार्मूला क्या है? वर्क डन पर यूनिट चार्ज, राइट? यहाँ से मुझे W मिलेगा, W को मैं वहाँ पे रिप्लेस करूँगा. सो इफ़ आई ब्रिंग Q ऑन दिस साइड, okay, so here in place of W I can write, what can I write? I can write V into Q, right? V into Q divided by time. So check this one out. What is Q by T actually? Q by T is nothing but the current, okay, charge per unit time. So that's it. I have got my first equation, V into I. So first equation, the relationship between power, voltage and current, P is equal to VI. So using the formula of potential difference, we can derive this formula. चलो ठीक है. Once we have got this formula, we can easily derive second formula. Check this one out. Let me derive second equation using Ohm's law. Ohm's law, because current and voltage is coming there, resistance is also coming. So it means I have to use Ohm's law. Okay, what is Ohm's law actually? V is equal to IR, right? V is equal to IR, right? So if I replace this V here, in place of V I can write I is equal to R, right? And I is already there. So ये क्या हो जाएगा? I square R. So we have got second equation as well, isn't it? Yeah. Okay. Third equation. Let me derive third equation. So third equation, let me erase all this part. ना ठीक है, चलो कोई बात नहीं. यहाँ पे मैं लिख लेता हूँ. Oops. Let me derive the third equation. Basically in third equation I want to replace I because I is not there, right? So I को मैं replace कर देता हूँ. तो using Ohm's law, V by I क्या हो जाएगा? Sorry, V by R क्या हो जाएगा? I हो जाएगा, right? Because I want to replace I, so I'm going to use this equation. V, I की जगह मैं क्या लिख सकता हूँ? V by R, right? V by R. So that is nothing but V square by R. Okay, so I have derived all three equations using the formula of potential difference, Ohm's law and current. This is how you need to remember these equations. Acha, there is a shortcut. There is a mnemonic to remember all these formulas. देखो, ये वाला फार्मूला अगर आपको ध्यान में रखना है तो आपको VIP, using this you can remember this formula. Very important person, right? So VIP, right? बराबर का साइन डाल देते बीच में, इक्वल टू का साइन. So VIP, isn't it looking like this equation? P is equal to VI, P is equal to VI, right? So VIP, using that mnemonic we can remember this formula. Let me write it down once again. V I P, राइट, बीच में इक्वल टू का साइन डालेंगे तो ये इक्वेशन बन गया. So basically all you need to do is remember the formula. This is how you can remember. Now what about this actually? There is a mnemonic for this as well. Okay, there is a mnemonic for this as well. So it goes like this actually. You must be knowing that poem, Twinkle Twinkle Little Star, right? So twinkle twinkle little star, really I'm not kidding, huh? Twinkle twinkle little star, power equals I square R. Twinkle twinkle little star, power equals I square R. Oh dear. Really? Yeah, this is the way you can remember this formula. Twinkle twinkle little star, power equals I square R. And what about this then? V I P. Okay, this is what you need to know actually. Forget the derivation. Don't forget the derivation actually. Derivation is for understanding part. But using mnemonics you can remember the formulas. V I P, twinkle twinkle little star, power equals I square R. Okay, forget the third one now. Koi baat nahi. 2 are enough. Now let me derive this formula. Okay, twinkle twinkle little star, what is our formula? Twinkle twinkle little star, power equals I square R. Power equals I square R. Now what is power actually? In case of these devices, okay, power का basic formula क्या? Work done per unit time. So they are converting heat energy per unit time. Okay, so I square R, that's it. मैं T को वो साइड लेके चले जाता हूँ तो ये मेरा हो गया इक्वेशन, राइट. Q stand for heat. In your textbook they have used H for heat. No problem. Okay, it doesn't matter whether you use Q or H, they both are applicable. So here they have written the statement. As you can see here, square of the current, heat is directly proportional to heat produced by the electrical devices like iron, electrical bulb or electrical heater. It is directly proportional to the square of the current, resistance and time. Time also matters here. So this is the formula for Joules law. So I hope you understood what is the meaning of Joules law here. Okay, it is regarding heating effect of electric current. So here our formula, H means heat. Okay, whether you write Q I square RT or H, both are applicable. Square. Acha, based on that there is a numerical here. A current of 2 ampere passed through a coil of resistance 75 ohm for 2 minutes. How much heat energy is produced? Okay, so what is the formula? H or Q? I square R into T, right? So I square, I is given 2 into 2, that will be 4. R is given 75 ohm and time is given 2 minutes. 2 minutes means 2 into 60 seconds, right? क्योंकि 1 minute में 60 seconds होते. So I think if you multiply this number you will get 3600 joule of heat energy. So I square RT. So basically you need to remember this mnemonic. V, very important person, VIP, बीच में इक्वल टू का साइन डालेंगे तो हमें ये इक्वेशन मिलेगा, राइट. सेकेंड वाला इज ट्विंकल ट्विंकल लिटिल स्टार, पावर इक्वल्स I square R. So this is how we remember the formulas for a long time, right? So these two formulas are enough. Okay, so that's it for today.